35%. That's the average performance uplift of the RDNA3 based RX 7900 XTX over the previous RDNA2 flagship, the RX 6950 XT. And yes, I have to admit, it's less than I expected. But this isn't supposed to be a doom and gloom video. Even though it's tempting, I'm not going to jump on the hate bandwagon and rage about my disappointment. Instead, I'm making this video to figure out what went wrong, and I'm inviting you to join me. So without further ado, let's take a closer look at AMD's new RX 7900 graphics card and the Navi 31 chip they're based on. I have to begin this video by figuring out why I was disappointed when we finally got independent performance reviews, because there's always the possibility that the product might actually perform as it's supposed to, and the true problem is your own unrealistic expectations. But I don't think this is the case here. Yes, I was a bit hyped for RDNA3, but not about its performance. For me, being the first GPU chiplet architecture was a much bigger focus, as I'm a sucker for interesting silicon design. Basically, since the very first time AMD produced its new RDNA architecture, their performance claims were on point. AMD claimed the 5700 XT could outperform the RTX 2070, and it did. Nvidia was even forced to release a super refresh. AMD claimed the 6900 XT could compete and even beat the RTX 3090, and you know what? It did. In 1080p and 1440p it was on top of many benchmark charts, and even in 4K it gave the 3090 a run for its money. So when AMD gave us a performance preview of their upcoming RDNA3 graphics cards just a few weeks ago, I did believe their claims. Right from the start of the presentation, it was immediately obvious that AMD could not compete with the RTX 4090. The lack of any kind of comparison gave it away. But the benchmarks AMD did present all showed a 50% or even higher performance uplift over the 6950 XT. I knew it wouldn't be 70% or even 60%, but I was certain we would see around 50% on average. As we know now, it obviously did not happen. AMD took the trust they built up over the past years and threw it all away in one single evening. That's why I'm disappointed. And to make matters even worse, I for the life of me can't understand why AMD acted that way, as they had to know independent reviews would burst their bubble before launch. But I digress. With the reason for my disappointment uncovered, let's tackle a more interesting question. Is there really something wrong with the RDNA3 architecture in general and the Navi 31 GPU specifically? Or is that just the performance we can expect from a first generation chiplet architecture with a graphics core die half the size of a RTX 4090? AMD's first RDNA generation also only matched Nvidia's second tier GPUs, and no one was especially disappointed by that. On the contrary, first gen RDNA got great reviews and made me buy a 5700 XT back then. So how do we figure out if the new RX 7900 GPUs are performing as they should, or if something actually went wrong? Since we don't know AMD's internal performance targets, we have to rely on things we do know. For example, the amount of transistors, the die size of Navi 31, and of course performance and power consumption data. After skimming through many different reviews, catching up with all the latest rumors, and taking the hardware specs of Navi 31 into account, it is my opinion that something actually did go wrong with Navi 31. Let me explain why I came to this conclusion. First, there is a huge amount of transistors AMD is spending on Navi 31, which does not at all relate to the performance gains we are seeing. Now, it's important to understand that increasing the amount of transistors in a GPU does not automatically equal a similar uplift in performance. Doubling the transistor count won't double the performance. Nvidia's RTX 4090 is a good example. The 4090, or rather the AD102 chip powering it, has 2.7 times the amount of transistors compared to the 3090 Ti. But the 4090 doesn't deliver 2.7 times the performance. In 4K it's about 65% faster. If we apply the same comparison to Navi 21, the chip powering the 6950 XT, and the new Navi 31, we can see much worse scaling from AMD. With 57.7 billion transistors, Navi 31 has almost 2.2 times the amount of transistors, but only delivers 35% more performance. Suddenly, Nvidia's scaling, getting 65% higher performance with 2.7 times the transistors, looks really good. And it gets worse, since the 4090 isn't even using the full AD102 chip, but a cut-down version with about 11% of the chip deactivated. A upcoming 4090 Ti could increase the lead over the 3090 Ti to 75% or more, whereas the 7900 XTX is using a fully enabled Navi 31. There is no way AMD designed a new dual issue shader architecture and built the first chiplet GPU on a new 5nm node only to achieve 35% more performance. It just doesn't make any sense. Long before there's actual silicon available, the performance of a new GPU is simulated and estimated. If AMD would have thought they're working towards a 35% increase in performance, this card would have never seen the light of day. It's also very apparent if we just compare the hardware specs of the 7900 XTX with the 7950 XT. The increase in raw FP32 performance, render output units, texture mapping units, and memory bandwidth alone points towards a much larger increase in performance than what the benchmarks show us. I come to a similar conclusion when looking at the power consumption. With every previous RDNA iteration, AMD achieved substantial performance per watt gains. The 5700 XT was over 60% more efficient than Vega 64. Same with RDNA2. The 6900 XT was 45% more efficient than the 5700 XT. And AMD did promise similar gains for RDNA3. Just a few months ago, they still talked about RDNA3 being over 50% more efficient compared to RDNA2. As a publicly traded company, AMD isn't allowed to lie about its products in such a way. It might even open them up to a lawsuit from investors. I'm convinced AMD actually predicted these efficiency gains for RDNA 3, and it does make a lot of sense. The switch to TSMC's N5 process alone should enable a massive increase in efficiency, but independent reviews show much lower efficiency gains. In reality, the 7900 XTX is only about 18% more efficient than the 6900 XT. With RDNA 2, AMD was more efficient than Nvidia's Ampere, but Lovelace completely turned it around and now leads RDNA 3 by up to 50%. I think it's very obvious that Navi 31 does have power consumption issues. AMD even stealth increased the TDP of the 7900 XT in the time between preview and launch from 300 watts to 315 watts, meaning it's now only 40 watts below the XTX. That's not something you do when you have your products figured out. Another good indication that RDNA 3 performs well below AMD's expectation is the ability to increase the amount of Infinity Cache by stacking additional cache chiplets on top of the memory cache dies. The early RDNA 3 leak by Angstronomics has turned out to be 100% correct so far, and it confirmed the ability of 3D stacking, which means AMD has implemented so-called TSV connection points into the design. We do have some low-res die shots, and while they are not good enough to visually confirm the integration of TSV into the chiplets, there is clearly enough space for it. The only reason for AMD to plan the addition of stacked 3D V-cache is if their simulations showed a much higher performance level, to a point where more cache is needed to feed the bandwidth-hungry shader cores. But as we can see from the reviews, at current performance levels, the 7900 XTX has more than enough bandwidth. And then of course we have all the rumors about possible hardware bugs floating around, from lower than expected clock speeds to higher than expected voltages and a non-functional shader prefetcher. And while these are all rumors, a lot of them are backed up by code from AMD's own driver stack or slides AMD has shared with the press. I'm certain RDNA 3 was supposed to perform much better. There's just too many hints and clues that support this theory. Now that we have established that Navi 31 missed its performance target by a pretty large margin, let's try to figure out what exactly went wrong. A little spoiler right at the start, I don't think it was a single flaw, but more a combination of multiple smaller bugs and issues within hardware and software. The most discussed possible cause are probably the clock speeds of Navi 31. Early leaks and rumors predicted very high clock speeds, well above 3 GHz, and AMD even specifically talked about how RDNA 3 is, and I quote, architected to exceed 3 GHz. At the same time, the official boost clock of the 7900 XTX is only 2.5 GHz. At first glance, this seems to be a pretty obvious shortcoming and would explain a majority of the missing performance. If the XTX would be clocked at 3 GHz, that's a 20% increase right there, and suddenly it would beat the 4080 by 20 to 25%. But that's not the entire truth. First of all, RDNA 3 being designed to exceed 3 GHz doesn't mean that the largest chip of this generation will hit these clock speeds. It's very common that smaller chips of a generation are clocking higher, like we can see with RDNA 2, where the 6750 XT has a boost clock of 2.6 GHz, while the 6950 XT tops out at 2.3 GHz. There's a good chance RDNA 3 has similar scaling. Navi 32 could achieve higher clock speeds, hitting the advertised 3 GHz. And second, the advertised boost clocks are often well below the actual in-game clock speeds. According to ComputerBase, in some games the 7900 XTX is clocking at over 2.9 GHz, coming very close to the promised 3 GHz architecture design, and Tech PowerUp even measured up to 2.99 GHz in games. This is for the reference card from AMD. AIB cards clock even higher and go well beyond 3 GHz. It's clear that Navi 31 is capable of high clock speeds. The problem is that it suffers from a pretty large clock speed deviation, depending on the specific games tested. In some games, the clock speeds are even below 2.5 GHz. Computer Base measured an average of 2.55 GHz across 18 games, and Tech Power Up got 2.63 GHz as a 25 game average. We can observe additional strange behavior when it comes to the clock speed and power consumption of Navi 31. For example, using a frame limiter has very little impact on the power draw of AMD's new GPUs, while Nvidia's Lovelace cards reduce their power consumption as expected. There are also idle power problems, some of which AMD has already labeled as software bugs in their latest driver release. All of this is a very strong indication that Navi 31 needs higher than expected voltages to achieve the desired clock speeds. The architecture is definitely capable of hitting fast clock speeds, but it often runs into power issues since the TDP is very close to the hard power limit a PCI Express slot and 2 8-pin connectors can provide. AIB models already show much higher clock speeds and thus quite a bit more performance, but because of the high voltage requirements, the power draw is getting out of control, which also hurts efficiency. The second possible cause for the worse than expected performance is still more of a rumor, but I think there's a good chance this is actually true. Quick intermission. I am currently editing this video, and Tom's Hardware just released an article with a statement from AMD that the shader prefetcher is in fact in working order. But I've decided to keep the discussion on this topic in the video because I think it drives home my number one point, that there isn't a single one flaw that is responsible for the suboptimal performance of RDNA3. With that, let's go back to the video. I'm talking about the claim that the shader prefetcher on most RDNA3 designs has a hardware defect. I'm not basing this just on unconfirmed tweets. There is actual driver code from AMD disabling the shader prefetcher on Navi 31, Navi 33 and Phoenix. This rumor goes hand in hand with the assumption that Navi 31 got released as a A0 stepping, basically the very first version of the chip that got taped out. Usually complex chip designs go through at least one, if not multiple revision changes before launch. With the knowledge that A0 silicon has a non-functional shader prefetcher, which again comes straight from AMD's own code, and AMD's labeling of retail Navi 31 GPUs as revision A0, there's a decent chance the shader prefetcher is actually non-functional on the 7900 XTX and 7900 XT. But as always, things aren't as bad as they seem, because while it would certainly be suboptimal, the performance penalty isn't that huge. On RDNA2, we are talking about around 5% performance regression without shader prefetching. It might be more for RDNA3 or maybe even less, but in any case it's not a huge performance impact if this turns out to be true. Still, another 5% down the drain, I think you can start to see where I'm going. Then there's the obvious argument to be made about the drivers. We all know graphics drivers can have a huge impact on gaming performance. Best example is the recent Intel Arc launch. But even in past generations, and especially for AMD GPUs, improved drivers have made a big difference. It even coined the term fine wine, and the shader architecture change within RDNA3 increases the reliance on optimized drivers because the dual issue shaders need so-called instruction level parallelism, and thus are harder to utilize than those of previous RDNA generations. With the switch to a new shader core architecture, AMD has to fundamentally change their driver optimizations, which does take time. And finally, there is the unknown factor of the first-gen chiplet architecture. I personally don't think it will have a large impact on performance, but die-to-die interconnects do use a lot more energy, as moving data off and on a chiplet is much more energy consuming than keeping it on a monolithic chip. A higher than expected fabric power consumption in turn means less available TDP for the graphics cores, and thus more negative effects on the performance. To recap, in my opinion, RDNA3 and Navi 31 specifically seems to suffer from a couple of different problems, none of which are a huge factor in of itself. It seems like Navi 31 does need slightly higher than expected voltages to reach the desired clock speeds, which means the chip is limited by the tight power limit and in general just runs with lower than expected clock speeds. It's not a huge drop. In some games the XTX can get really close to 3 GHz, but overall it's a performance reduction. Then Navi 31 seems to suffer from a hardware bug within the shader prefetcher. Again, not a huge problem, but still around 5% performance regression. Next, RDNA3 is using a new shader architecture, which means driver optimizations can't be copied from previous RDNA generations. and the specific dual issue shaders are also harder to optimize for. And last but certainly not least, the first gen chiplet design could take a bigger bite out of the TDP than predicted, further reducing the available power for the graphics card die. Each of these problems alone are not that impactful, and almost any chip of this size suffers from bugs and issues, especially when using a new architecture, implementing a new chiplet design and using a new process node at the same time. But combined, they have the potential to severely decrease the performance of Navi 31. You might ask yourself now, how can something like this happen, and why would AMD release such a seemingly broken GPU? Well, first we have to remember that up to this point, all of these supposed bugs and issues are unconfirmed. There might be very strong indications that it's true, but right now we only have circumstantial evidence. I try to make a convincing argument, but unless AMD comes out and openly confirms or denies these problems, we won't know for sure. We might get some confirmation once Navi 32 releases, which is supposed to use a fixed version of RDNA3, but until then we have to wait and see. As for the how and why, here's a possible explanation. Imagine AMD just taped out Navi 31. The design is finished and first samples are being tested. They show some promise, but it quickly becomes clear that more metal layer revisions are needed to get the voltage requirements to a more acceptable point. Nothing uncommon, most chips take multiple metal layer revisions and sometimes even silicon layer revisions to fix hardware bugs until they get released. But then the engineers discover that the shader prefetcher doesn't work. No reason to initiate a metal spin if the silicon layer needs fixing too. But it takes longer than expected to figure out why the prefetcher isn't working, and then even longer to design a possible fix. By now AMD is too close to the promised launch date. A complete respin would take at least another half year, and Navi 31 would launch in the second quarter of 2023. The only other option is to do a metal layer fix before launch. But it's also a waste of money and resources to fix the metal layer in order to get the voltages and power draw and clock speeds up to snuff when there's still broken silicon inside. Another problem for AMD is that they have booked a lot of 5nm capacity at TSMC. It's a waste to not use it, and even with all its problems, Navi 31 is still faster, more efficient, and probably cheaper to produce than Navi 21. As a result, AMD begins production of A0 revision Navi 31 chips to hit the promised launch date in Q4 of 2022. Now, this is a nice story, but nothing more. I was just trying to explain how such a situation could arise and why it might still be the better choice to release a slightly broken product. Maybe none of that is true, or maybe I exactly hit the mark. We had similar GPU launches in the past. If you remember Nvidia's Fermi generation and the corresponding GTX 480 GPUs, you know what I'm talking about. In September of 2009, ATI released their Radeon HD 5000 series chips, with the flagship, the HD 5870. It was 30 to 40% faster than Nvidia's GTX 285, consumed less power, and was the first GPU to support DirectX 11. Nvidia clearly didn't expect that kind of performance. It took Nvidia 6 months to release their counter, the GTX 480. It did beat the HD 5870, but also consumed a whopping 50% more energy. It was loud and hot. Then, a few months later, in November of the same year, Nvidia released the GTX 580, which was basically a fixed version of the 480. It increased performance by about 15% and at the same time consumed less power and was cooler. The 580, in very simplified terms, was just a respin of the 480. By the time the 480 had launched, Nvidia must have already taped out the 580. But Nvidia couldn't have waited another 8 months to counter ATI, because by the time the 580 released, everyone interested in a high-end GPU would have already bought a 5000 series card. So Nvidia decided to launch a partially broken GPU. Another example are AMD's Vega GPUs and the hype about their primitive shader feature. It was teased and rumors for a long time, but apparently broken in hardware. And as far as I know, it never got fixed. Next, I want to talk about if and how Navi 31 can be fixed. This discussion is highly dependent on how accurate my previous predictions turn out to be. For example, if the retail Navi 31 GPUs are actually not A0 stepping and already have a fixed shader prefetch, there is no more performance to be gained. Maybe the large fluctuation in clock speeds are related to bugs in the power management, which might be fixed with software, so a metal layer revision isn't needed. Maybe the drivers are already as good as they will get, or AMD will release a 30% miracle driver in a few months. We simply can't know for sure. But if my predictions are correct, Navi 31 does not need a lot to go from an okay product, which really is only okay because the competition in form of the 4080 is probably the worst price to performance GPU ever, to a actually good product. We don't need a miracle driver. There doesn't need to be an amazing metal layer revision that boosts Navi 31 to 4 GHz clock speeds. And there also doesn't need to be a hardware fix that doubles performance. By now, AMD will know all about the bugs and issues within Navi 31 and understand how to fix them. Imagine a B2 revision Navi 31 being released in the summer of next year. The shader prefetcher does work now and adds about 5% more performance on average. A couple of metal layer revisions improve the electrical properties of the GCD to a point where the average clock speeds are now 300 MHz higher. Instead of 2.55 GHz, it's hitting about 2.85 GHz on average. And because of the lower voltages, power consumption does not increase. That's another 10 to 12% performance on top. And by summer, AMD's engineers have further optimized the drivers. Not by much, but they are able to achieve an average of about 6% more performance. If we add all those little bits together, the 5% from the prefetcher, 12% from higher clock speeds, and another 6% from driver optimizations, suddenly the 7900 XTX is 23% faster while consuming the same amount of power. That means it beats the 4080 by 20 to 25%. The power efficiency is now over 40% better than RDNA3 and much more in line with previous generations. And even the 4090 wouldn't be that far ahead anymore. Navi 31 doesn't need that much performance uplift to become a good product. Even just 5% more clock speeds, 5% better drivers, and 5% prefetcher gains would still place it 15 to 20% above the 4080 while being cheaper. And then there is ray tracing, probably the only part of RDNA3 where I was positively surprised. Remember the reveal where AMD fooled us with their numbers? They only did so in pure raster performance. They talked very little about improvements in ray tracing, and I took that as a sign that RDNA3 doesn't really uplift ray tracing performance, at least not more than traditional rasterization. But it turns out that while the 7900 XTX is only 35% faster in raster than the 6950 XT, in ray tracing, the lead is almost 50%. RDNA3 has much improved ray tracing performance. It competes well with a 3090 and even a 3090 Ti. That was a huge surprise and something I would have put more focus on if I was in charge of AMD's presentation. This strong performance in ray tracing also means that the 4080 is just 25% faster than the 7900 XTX. Yes, I said just, and yes, 25 is a lot, but it's much closer than I expected it to be. And if AMD manages to improve the rest of the performance of Navi 31, it will also affect ray tracing performance, since the performance penalty is mostly percentage based. As much as I would like to continue talking about possible ways RDNA3 might be broken or could be fixed, I have to come to a conclusion. The reason I made this video is not to pretend that I know exactly what's going on with RDNA3 and how to fix it, but to give an insight into my thoughts about the current situation and to initiate a discussion that goes beyond AMD bad or 7950 XTX will wipe the floor with Nvidia. While some semiconductors might be botched by one huge flaw, it doesn't need a fatal flaw to turn a promising product into an underperforming one. I don't think RDNA3 and Navi 31 have a single flaw that will either be fixed or not. I think it's a accumulation of different small problems that combined severely limit the performance potential of the GPU. I also don't want to defend AMD in any way for their botched performance numbers in releasing a potentially suboptimal version of Navi 31, but to explore why certain circumstances force certain actions. I am super excited to see if my assumptions will be confirmed in the future or to learn where I went wrong. I'm sure I'm not the only one with an opinion on what's going on with RDNA3 and Navi 31. And of course, I would like to know what you think. Do you agree with my assumption that there are bugs within Navi 31? Or do you think everything works fine, but AMD's architecture just isn't that good? And if you believe there are issues, what's your opinion on possible fixes? Do you expect a 7950 XTX, or is that all nonsense to you? Maybe I made an obvious mistake somewhere. Leave a comment down below with your thoughts. You know what to do if you enjoyed this video, and see you in the next one.